And I'm gonna start with Scratch here, just because I know some students have had like some issues, like even going through the process. So I'm gonna go over this many times. Um, this is an intro to level design class, so like introducing new tech and having problems are all part of the process. So don't be nervous if things crash or you have a hard drive fail or something happens. These are meant to be projects that could honestly be recreated in a weekend if you had to, so that you could submit. And then my big advice for anyone that has those catastrophic incidents, just document them. Because I know you, I've worked with each of you, I've seen what you've been doing week to week. So just document it and say, hey, my laptop fell into the pool or fell, and I lost all my work and there's no way to retrieve it, but here's what I did, and and these are the updates I'll make within reason to get the assignment done. I will take into account the stuff that doesn't work. One of the big things I've been watching on I try to watch frequent GDC talks, but one of the big things that some of the other schools are, they do these 1 week game projects. So they'll have a class, they'll have like a 16-week class, and you have to make a new game every week for those 16 weeks, right? And they take into account the failure ratio of that. So what they do is they say, hey, you have to make a game every single week, but tell you what, we'll only grade 3 of them. Right? So you get tons of chances to fail, and then you're only graded on your successes, right? I mean, that's the way life is. That's the way projects are. That's the way deadlines are when you get into a job. Is failure's okay. At the end of the day, they just want to see enough of that success so the project chips on, right? So we're going to start from the beginning. We'll launch 5.1. Piece of paper with me. I do. Yeah, and in the future, not always guaranteed, but I like to get in the habit of doing a lot more recordings, even if it's like tech stuff like this. Because we do have students that have like issues or can't make it to class, and it's nice when they send me that email. Can you tell us what we did today? And it's like, yeah, here's the video. Like we made a coin pickup. So we're gonna make a coin pickup. Let's just start with let's just use some previous Hello Minecraft level. Actually, no, we're not going to do that. Sorry, I'm going to start from scratch, because that's what I said I would do. We're not going to start from a pre-built thing. So I will edit this out in post. Although that is a beautiful Minecraft level that I think I did in... Was that in this class? Did we make it here? This won't take as long. We're going to start bare bones. So this is Unreal 5.1.1. It's on 5.3.1 now, but we're just to keep it safe, we're going to use an old one. We're going to create a new game. We are going to use, okay, we're going to set it to Blueprint. We're not going to code in C++ because that's for the engineers to worry about. Platform is desktop quality. We're going to set that to scalable. And this is especially beneficial if any of you have computers that are less powerful. Set it to scalable. Essentially, it used to be maximum or mobile. They used to call it mobile. Now it's called scalable. Basically, it takes the settings down really. All the performance heavy stuff are checked off, so that you do have the options of checking those back on, but it's a little bit more sensitive to lower performing PCs to work on. And then we do want to include the starter content, even though I tell everybody not to use existing assets. I'm especially clicking on the starter content. There is a gold material that we could just use, and I'll show you for a second, or we can make our own gold. We're going to talk a little bit more about materials and a couple small things we can do to add like some roughness and metallic material to it. But it does have is a particle effect in there, which is some explosions, which which in previous courses, I had them use one of the pre-built explosion sounds and one of the pre-built explosion particle effects for the coin pickup. And my argument for that was the whole thing is, as a level designer, we're not effects designers and we're not sound designers. So we kind of use what we have. But over the years, I would have all these location study projects with coin pickups with explosions, particles, and sounds in it, and I can't take it anymore. So we're going to actually use a Mario coin sound that I added to Canvas, and then we're going to take that explosion sound, the effect of that explosion, and we are going to duplicate it in class today and do just enough to make it suitable for a coin pickup, right? And kind of show how you can reuse assets to not reinvent the wheel and just use something to make it more of what we want it to be. So that's what we're going to do in class today. And point of fact too, if it annoys your teacher that they're seeing the same thing over and over again, imagine sending that out to job applications where, for example, if I've taught hundreds of students and they're all getting a location study where it's an explosion coin, right? It's gonna be very recognizable. So I'll say this: when we create this project, feel free to change the pickup to something else. I've had other students turn them into cookies and it says a crunch sound when you collect it, right? Or it could be a weapon pickup. It could just be a shiny orb. You can easily change it based on what we'll learn today to be unique to whatever your play space. If you're running through the stadium, they might be footballs you're collecting. I don't know, or if it's the Goatman's thing, it might be pentagrams. We'll do that. I don't know. Just some ideas. It could be something other than just coins. Okay, so let's start off. We've got the scalable. I'm going to change the name to Coinlandia, because that sounds better. And we're going through the whole process here. And then we're going to just hit create. And that's going to create our default level. The reason I don't like the starter content is because it bloats my files. It's going to have a lot of content we're not going to use. So usually, a lot of times, I'll start without creator content, and maybe in the future we'll go over it. But since this is an intro class, it's not an effects class, but we want to touch on a lot of this stuff because we can use those as tools as level designers. What the heck is this even? What did I start it as? I didn't start it as a third-person template. Wow. Okay, this is not what we want, class. Let's pretend that didn't happen. It does look pretty. I kind of want to start in it, but we're not going to. Portlandia, or Coinlandia, needs a new name. Luckily, it's starting faster now. All right, so games. We're going to click on games. I think it was on blank. Okay, we're going to go to third person. That was our big mistake. And now we can't. Can anyone think of a good name? Coin Town USA. Okay. That's the right one. Okay, C++ desktop. We're going to scalable, including our starter content. We're going to hit create. All right, so here's our starter content. We're going to leave it as is. This is the third person template. Already has a playable space for us by default. We hit play. We can run around. Perfect. That's all we need. This is one of the beautiful things. Actually, one of the discussions I had yesterday, even with Gearbox, even for like a level design class and even building this stuff, that was his comment, is start you off with something that already works that you can start building a level with. And that's what I love about, honestly, Unreal Engine and these templates, is because we don't have to worry about the third person camera. We don't have to worry about the character or the animations. We've already got a run, jump, walk. And if you want to do an FPS game, it'll come with a tennis ball that it shoots, right? So it's got everything you need to just start designing levels. It's kind of perfect. So hit escape, go out of that. So we need to create that coin pickup. So we could start off by saying, what if we're just working in primitives and working easily, what should we start with to create a coin? What primitive shape would help get us there? A cylinder, right? So a cylinder already shaped like a coin, maybe even a stack of coins, right? But we just want to shrink it down into one. But we need to create that thing, that object that we can put code to. Something that we can associate blueprints with that physical object, that digital object. And the way we do that is something called an actor. It's in Unreal, an actor is something you can act on. You can put actions to. So to do that, we're going to go to our content drawer down here at the bottom. And just to keep things organized, I'm going to create a new folder. So you can see here, I have a third person folder, starter content folder, level prototyping folder, and a characters folder. Kind of all the basic stuff we need for a starter third person level. And just to keep things organized, if I hit right, if I right click, I have some content objects that pop up. And we're going to click up here, fourth through the bottom is a new folder. And we're going to name that BP. Actually, we'll just call it the coin folder. Just to make it super obvious. And it can't contain, can't contain a space. A Fodler, and I can barely even see it. The type is so small. Folder, my friends. Okay. Hit enter. We're going to click on that coin folder. We're going to right click again. And now we have some more objects of things we can create for a level. You can see you can create a new blueprint class, which is that's what we're going to do. You can create a new level, a new material, or a Niagara system. And Niagara system is Unreal's particle systems. We're going to play a little bit with Niagara lightly today, super lightly. So lightly that I'm not a big particle effects guy. That's actually when we set personal goals of things I want to learn more of. Niagara is on my list of things I want to dive deep into. Eventually, here at UNT, I want to have more effects classes, so actually get effects experts. That's its own class to go over how to make those effects in games. But we can learn enough that we can improvise. So we're going to learn how to improvise a little bit today with the Niagara system. But let's click on Blueprint class. This is going to be what's going to hold our coin pickup. So we can create a pickup that we can place multiple times in the level and not have to remake any coin. We can just be a once-off. So we click on that Blueprint class. I can't speak. And it'll ask you, what are you going to make? What is this Blueprint class? It can be an actor, it can be a pawn, a character, a player controller, a game mode base, actor component, or a scene component. A lot of stuff we don't have to worry about. We're going to pick the first one, and that is an actor. So now we have this new actor, and we are going to call it BP coin _ coin. Hit enter, and you can see now we have basically this blank slate to create our coin pickup with. And if we click on that, we can actually drag that now into our scene. And it's a little circle. It's a little dot. It's basically, that's just telling us where that thing is. Because nothing exists there, so they put a default little, there's something here. So that if you have those empty volumes in your scene, you can still click on them and adjust them. But there's nothing inside it now. And like we said, the closest thing to a coin would be a cylinder. So we're going to open our content drawer again, and we're just going to double click on that BP coin. There it goes. And you can see right here, we have three viewports to worry about. One is the viewport where you can actually see the object. So if you had a character or anything else, this is where you actually see the character, see the animations. You have a construction screen we're not going to worry about, but then you have an event graph, which essentially this is where our code for our blueprints is housed in that. So the first thing we want to do, though, is create the coin. We want to see what it looks like. We want to create a mesh for it, right? So over to the left, you'll see this component section. This is where you can create those attributes that actor will have. And like you said, we're going to click add, and you can see there's a ton of Garbo that we can choose from. Probably more than is even visible. So how do you think we can find a cylinder? Just start typing it in. That's the beauty of almost everything on Unreal. If you just know what you're looking for, you can find it. And this is where the biggest challenge is going from like say Unity to Unreal to Godot or any other engine is they name things differently. So like the blueprints nodes, and so a lot of this getting familiar with Unreal is honestly getting familiar with what's in it. And I've taken a lot of classes over the years where they take deep dives into software, whether it's ZBrush or Maya, and they kind of cover everything. And I found when a class covers everything, what do you remember? At least for me, nothing, right? So especially for an intro class, I try not to go too deep because the things I show you, I want you to remember because these will be 80% of the things you'll use. These are the things you'll use 80% of the time. And if you take equal time on the 20%, it's not really an intro class. It's a deep dive. So we're going to start typing in cylinder, SYL, or even just CY, not S, by the way. I know how to spell cylinder. And we're going to click right there. You can see cylinder pops up. So we click that, it pops up into our class. And if I move this actor editing view away, you can see that cylinder actually shows up in my screen now. So that it's no longer a container. It actually has the asset that's in that container propagated wherever you have that sitting in your level. So in my level right now, I can actually take that coin actor and hold down Alt and move it around. So we have multiple of them in there, right? And if I hit play now, you can see I've got the beginnings of my coins chilling there. They don't look like coins yet. So let's quickly turn these into coins. Let's answer the door. Okay, so to edit this coin, to make it look like a coin, we need to scale it down and squash it. We can do that with the same kind of tools we have in the level editor. We have translate, we have rotate, and we have scale. So if we change those, you can see you can scale it down more like a coin. And you can also see over here on the right, you have the transform options here. In numbers, I find that I usually keep the grid snapping on, so it won't quite look the way I want to if I just use the grid snapping. And so we're going to play with these scale attributes over here. So I've done this before, so we're going to try 0.1, and then we will try 0.5, see how this looks for the size of the coin in there. So I'm just doing 0.5, 0.5, and 0.1. And so it's X, Y, and Z. It's the 3D space, so we're scaling that down. Now it looks more like a coin, so if I go to translate, move it up just a little bit. If I look in my scene, it's matching whatever I do in here, right? So the beautiful part, why I like to have it actually in my scene too, is because I can see how it will look when it's played, and it's kind of that one-to-one thing. But obviously a coin wouldn't be floating flat like that. We're going to gamify this, so we're going to rotate it 90 degrees. Let's hit the rotation tool. $90 degrees. And let's take a look at it in game. All right, kind of looking like a coin should, right? Aesthetically, though, does anything bother you about that? It's not moving, but yeah, it's kind of down to my feet, right? Like typically, like in a game, you want the coin kind of up to the chest. And this is interesting. Notice I'm moving it up, but the pivot's actually right here. Funny story. I was actually working on. We showed the Disney Infinity last week. So when I was working on the Incredibles playset, they were working on that set, and then they were working on the version too at the same time. And we were sharing a lot of the assets. We had all these capsules that were in our world, and when they created those capsules, the pivot was on the center. So if it snapped to the ground, it would be halfway flipping through the ground. So what I had to do with the 300 capsules that I had to put around Metro City, each one of those individually I had to raise up to the correct space. And if you have to do that by hand, guess what? They're not all, it's not going to be uniform. And it bothered me. So one night I got into, they weren't called blueprint actors at the time, we just called them capsules. But essentially, I got into this blueprint file at Disney and I said, you know what, I'm sick of doing this. I want it to be the perfect chest height for all my characters. So I moved it up a couple meters. Hit compile, saved it. The next day, everyone screamed at me because every single capsule for the entire game was now moved up 2 meters. And they were really upset about it. And there was good reason in the toy box mode because of the way they placed things a la Minecraft. They actually wanted it centered so because they put a box around it, like a voxel box, so you can position it and click it on a grid-based system. So when I had done that and moved it out of the grid, they were really upset. And so we have this like internal argument where it's like, well, I hate the way you're doing it because it messes me up. And they would come to me and say, well, I hate the way you're doing it because it messes up over here. So the solution was actually they had an engineer go into code and adjust it so when it was in my mode to the right position, and when it was in their mode, it stayed where they wanted to, because both reasons were valid. But yeah, that kickback is kind of important in design because I'm like, guess what? Like, it's taken me hours longer. Every time I have to adjust one of these capsules, I have to go in and adjust 300 of them in my level. So any kind of change we make is propagated. It's time. So if I had gone, it's one of those things where if I had actually gone into a meeting and proposed that, it might have been shot down. But where I was a jerk and I just did it, it actually caused change. And so I always kind of explain that, like, don't, like, there's experience that comes with that where you do it diplomatically, but change usually comes because of actions, not because of thoughts. If that makes sense. And so a lot of students I have will actually talk themselves out of doing things or moving forward on plans because, oh, well, I don't think it'll work because of this or this or this. It's like, this is where as professors, and honestly, as someone trying to prepare, just do the thing. It's okay that it doesn't work right. We'll fix it. But the action will create another action, which will get you to that right position. But yeah, so that's where we're at with this coin. So we want to raise it up a little bit. Long way of talking about this coin, but we're going to raise it up. And we'll eyeball it. I think that kind of feels good. Now, whenever I grab it, this is where the manipulator is in world, and I know if I just put that on the ground, it'll be at a good height for a player. So Aaron mentioned something else that this was missing. Yeah.
Is the manipulator like just arbitrary?
Yes, no. I think as long as that, yeah. Essentially, it's a for this point case, it's a set point. It's in the world of that object that I'm creating, that coin, it's 0, 0, 0, right? Because that's what I'm moving that coin up from 0, 0, 0 in that class, this little container. Essentially, you're taking that coin. So for this one, if we're spawning the coin in, we would say this point of space is where it's going to spawn from. But essentially, this is just a point of space.
So when like there's an interaction with the actor, is it the model or the
Let's look at that. Yep. So
that's still just within the
yeah.
So the hitbox that's independent of the model.
Right. So if I didn't have this object in here, this little visual context would be nothing in the game. It's just a location.
It's a location from which
X, Y, and Z coordinates for where this thing will sit.
yeah, the location from which everything else about the object.
Yep. So as you can see right now, we can run into this thing. It has collision by default. We can even jump on it, right? But it's not the manipulator, it's that actual object that comes in. And because we're creating an actor, we only have to create one coin. And if anytime we spend that coin is well invested, because now if I have 10 of those for my level, I can put it wherever I want. If I delete one of those, it doesn't matter. I still have it in my browser. It's in my contract drawer, which if you think about a drawer in real life, that's where my coin now sits that I go and put on my right? But we have an infinite volume of those. I can grab as many of those want and put them in the play space. So it's just sitting there, doesn't look much like a coin. A few things bother us about this. One, you shouldn't be able to just stand on a coin, right? So now we make our little task list and what we want to fix next. It doesn't, it's not, if we want to put a coin color on it, maybe that's not the most pressing issue. Something we want to do. One, we want it to spin around, so we'll notice it. And two, we don't want to stand on it. So maybe we'll just turn the coin off for now so we can pass through it. Right? So let's start with the first one. Let's add motion to this. And without going into animation or too much detail, there's a component already built into Unreal, just like we did with a cylinder. We're going to add an attribute to this. So we're going to go back to our add component and click ROT and select rotating movement. And we're going to click on that, and it adds a new component here underneath BP coin called rotate movement. It has attributes over here, which is a rotation rate, and then you can even pivot it. But right now it's set to 180. Can't even speak. 180 on X, which means it's going to move 180 degrees every second. So we can speed that up by saying we want it to rotate 360 degrees every second. Maybe to slow it down. But every second it's going to move that much distance, right? So by default, 180 degrees. I'm going to be honest, it's probably going to be okay. So we're going to compile this. Hit save just to make sure it works. Just get used to compiling and saving. And we're going to hit play again. So not too difficult to add a rotating movement on it. Like, these are one of those things as a level designer, they're like, this is at our disposal. Like, honestly, if you have like a fan or something you can rotate on the ceiling just to give the player more realism or more life to it, pretty darn easy to add something like that just really quickly. You create an actor, put a rotate on it, it's moving. See, the problem with it still is it's moving, sure, but if we jump on it, you're going to get nauseous and sick. It's still got that collision, which is making me kind of sick, but you can see it propagates to all of them. So pretty cool. Now we have these coins situated all over in our level. It took us, if I wasn't talking so much, it would have taken about a minute to do, right? So next step, we're going to change the color. So if we click on the object right now, we can actually go into the material section over here. If I just wanted to make it really simple, right now it's a basic shape color. We could type in gold, and there is a material called gold in the default textures. And we can save that, hit play. We could leave it at that. It's actually not too bad. Kind of breaks my rule for the class of no textures. And I think these are actually just roughness maps that give it the illusion of textures. But one of the beautiful things about using these templates is we can kind of re-engineer some of the stuff. If you want to learn how something's created, look at its components, and you can kind of dissect it. Reverse engineering is like one of the best problem-solving skills to have in games. Is look how someone else created it and see what you can glean from it. It saves you time from having to look up tutorials on a lot of things. So right now there's already a gold color in here. So let's look at, just out of curiosity, let's open our content drawer. And if we go to our main content folder, I can just type in gold. And I can find that material in my content browser, which is right here. And if we click on that material, you can see here's how they made that, which is kind of a hot mess of spaghetti and material code, right? So if we go down to its base node, you can see there's a component going into color, to metallic, and roughness. And normal, the normal map is actually what's giving it that physical, like giving that texture an actual appearance of like pits and cavities on it. And so I'm like, okay, well, if we create a new one, we'll forget about the normal because that's kind of textury, but the components we kind of want to look at are color, metallic, and roughness, like how rough or smooth an object is. Like, all right, let's play with that. Let's make it a little bit more simple for the class, though. So if we exit out of that one, we're going to create a new material. So we'll go into our content folder, and just to keep it all in the same space, we'll look up our coin folder, and we'll create a new material. And we'll call this M underscore coin gold. And I call it coin gold. That way I know if I search anywhere for coin, it's going to show one of the things I've created, which makes it easy. And so we're going to double click on that material, and you can see I have that base color material we had just like we did for that gold color that was a little bit more complex. So if we want to create a base color, we've done this before in class, what do we need to create? A constant 3 vector, right? Because that holds the data for the numbers that create up a color, that make up a color, whether you're in Illustrator, Photoshop, any other kind of Home Depot creating a color, they kind of use that same color swatch, RGB colors. So we're going to click on that base color, move it out, click on constant 3 vector. Basically, you notice they have constant 1s, 2s, 3s, and 4s. It's just, it has a set of numbers. Constant 1 is just one static number. And Aaron, I apologize, it's probably old news for you. We're putting you to sleep over there. Okay. Welcome to Capstone. What's your capstone project?
Stuff with the extra.
Oh, cool.
Visualizing your,
Oh, fun. Gotta get you. It's one of our talks yesterday. Is like, why do you need 2 semesters for a capstone project? I'm like, 2 semester games. Got to do it. So games would be much funner to me than satellite data, but it might be super entertaining. Okay, so this constant, we want to create a color. We don't have to know the numbers. If we just double click on this color tab, we can choose something that's kind of orangish and change the tone up to be a little bit lighter. We're going to hit OK, and we're going to apply that. Takes a second to propagate there, but now you have we have somewhat of a coin color, right? So now we want to play with the roughness. So we're going to drag that off, but we're just going to do a constant 1 because we just need one number, basically 1 to 0 or 0 to 1. And so we'll type in constant 1 vector, which is just a constant. And it just has a value of 0. So we hit apply on that. You can see it's 0 is super smooth and shiny. So it's basically like a glossy coin ball, which is kind of cool. Maybe we want it to be like that. But just to show you how you can adjust it, we can change it to 0.5. And then it's got like a light shine on it too. If we want to go metallic, we can do the same thing. I'm actually just going to Control-C, Control-V. See if that works. It's not working. Bummer. Thought it did work. Yeah, there we go. Control. We actually just copy and paste anything in Blueprints too, which makes it super easy. If I want to make another constant 1 vector, this one's 0.5, and we'll pump that into the metallic. And maybe we want to change that metallic-y color. Maybe we'll change that to a 1. We'll see what happens. But you can start to look a little bit more metal, has a little bit more shine to it, right? So this is like a simple version of the gold. We'll hit apply and go back to our coin, which had the previous gold texture on it. Oop, zoom in on it. And we're just going to go over here into its materials again and give it ours, which is M coin. And to me, it's just a little bit cleaner for a prototype kind of blockout level. And it's good to know how to make your own materials. So that's why we go through that. So we have our new coin. It's got color on it. Before we even jump in, we talked about the collision. We don't want it. We don't want to be able to stand on this coin. We want to be able to touch it, but we don't want to be able to stand on it. And so I found, because of other classes, it's easier just to, honestly, we'll just turn the collision off of the coin itself and create our own collision to create a trigger box. We'll do that from scratch. So we're going to take our coin, and down underneath the detail section here, we've got, someone sees it. My eyes are awesome. We're going to go down to the collision right here. And right now it's set to block all dynamic. So anything that has movement or can move, it's going to block it. We're just going to turn it off completely to no collision. We'll hit compile and save. Hit play. And you can see we can walk right through it. And honestly, I would rather have this, if we couldn't do anything else, I'd rather have this as the default than having it block me or stand on it. Like if I couldn't do anything else, I would rather have no collision than any collision on that. Because at least it gives the illusion, if you wanted to imagine you were collecting it, you could. Kind of breaks the illusion when you can stand on a coin and twirl around on it, right? But that's not all we can do. We can actually make it disappear. So to do that, like I said, we don't have anything to collide with now. We've removed it all, so we need to create something. And I kind of talked about the cheapest versions of collisions are a sphere, capsule, and then a box. And then the more complex you go, the more processor intense it is. So we're actually going to create a sphere collision on this coin. Even though the coin isn't shaped like a sphere, as it rotates, it actually kind of it covers a spherical shape. So it kind of works out really well. So let's go to our coin here. If we go into add component again, we're going to just type in COLL, and you can see we have some collision choices to choose from. We could create a box collision, a capsule collision, or a sphere collision. You can create geometry collision, but you'd have to import that or have it preset to that object. By default, Unreal will create complex collisions now. It used to be a lot more difficult. Unreal 5 kind of upped a lot of that, but we're going to create a sphere collision. And you can see right now, it's set to the wrong place, right? It's set down to our pivot. It's set to 0, 0, 0. So just like we did with the other one, we're going to move it up. And it's already a pretty good size. It kind of goes a little bit larger than our coin. We could scale it up or down. For coin pickups, I like to say if you're close enough, you get it. So we make it a little bit bigger so that if you get close enough to that coin, you're going to collect it. And so we're going to hit compile. And now for the moment, we're done with our coin. It spins. It has a trigger box or sphere. It has a trigger volume that we can enter so that we can find out when it is collected. But now we need to make it do something. So what happens to a coin after you collect it? Poof, it disappears, right? It goes into an inventory. No, but it disappears. It's no longer in the play space. So we need to make this disappear. So how would we make this coin disappear? What do we need to do? What's that? Destroy it. We need to destroy it. We're just going to kill it because that's the easiest thing to do. The more complex thing to do is what it has in the space. It has something you can collide with, and it has something visual. We could turn all those off, but then they're still in the scene. We just want to get rid of it altogether, right? So we're going to destroy it. So we're going to go into our event graph now. So the event graph is where you edit your blueprints. It's where you do your visual scripting. Essentially, this is coding. If you never take a programming class, honestly, and you only stuck with visual scripting, you can make a game. You can make a full game with this, right? There's power to learning C# or C++. That's why engineers are so incredibly valuable, because they're faster, more efficient, and they can fix problems, they can edit things, they can give you tools. But if you had to, as a designer, if you wanted to make an entire game from soup to nuts, you can do it in Blueprints. That's what's pretty awesome about these. But if you just want to prototype something quickly for a level design class, it's phenomenal as well. So by default, they give you a few different options. We could delete these if we want, or we could just use one of them. But it's got an event begin play. It's got an event actor begin overlap, and it's got an event tick. So we're not going to worry about any of these except for the overlap. But the event begin play means whenever that item is created, it will send an impulse. It'll send one of those nodes to tell that thing to do something. Or if it's a tick, you can actually set that to, hey, every 10 seconds, it's gonna do something. And then from that, you can play with it to set the time, duration, and random. You can make it do a lot of things. But for this one, I want to know when the player overlaps with that sphere. I want to know when the player's capsule collision touches our sphere collision that we just created. And that is the event overlap. And they put some comments on it too. This event is when this actor overlaps another actor, for example, a player walking into a trigger for events when objects have blocking collision. So it'll tell us that. So if we actually want to use this beginner one, we can bring it out. And before we even destroy it, we can find out if it's doing what we want it to do by doing something called a print string. And this is a huge debugging tool. Like if something's ever not functioning the way you want, or it's not doing things, well, let's make sure that this event is actually ticking off. So we can create a print screen before we even destroy it, just to see if when I walk through this, it's doing what I want it to do. So we're gonna say, let's type in print and call it print string. Right now it just says hello, and that's fine. When I walk through this coin, I want it to say hello. So we can make sure it's even working. So we're gonna hit compile and see if this works. You can see it up in the corner, it says hello, right? So when we've overlapped the collision on this object, it's saying hello. Boom, it's getting us there. So now Rio mentioned we now want to destroy the actor. So now we know when the player walks through it, we are getting an event. So we're successful. We now know when the player collects that or touches that coin. So that's 90% of this. So a lot of stuff in Unreal just makes sense. Like if we know we want to destroy the actor, we can now we'll just delete this print screen. We can drag from this event that kicks off, and we can say destroy. But you had to know that it was destroy actor, right? It's not kill actor or it's disappear the actor. It's destroy, and that's why learning these terminology is helpful. That's why I record this too. So if you need to redo it, it's like, what did he say? What did he call that? So now it's destroy actor. And the target is set to self because we're telling Unreal to destroy something. It has to know what to destroy, right? So we're telling it to destroy itself. This BP actor class. We could actually pipe in this other actor and it will actually detect who touches it and it will destroy the player, right? So you can see how we can use the same logic. If that coin was something you don't want to pick up, we can actually find out who touched it and kill that thing. You can see how we can turn that coin quickly by adjusting some of this logic to turn into an evil coin, right? If we wanted to. Color it red, have it laugh when you touch it, ha ha ha. A lot of power comes from that. Like this coin pickup, I love teaching this class because it really opens up the floodgate to everything you do, right? So if we change this coin to a key, right, you could collect that key. Now that event could go off, you could open a door, or you could switch a camera. Like that, trigger volumes are probably the most powerful tool in game design, level design, or any kind of digital medium that you can use. Okay, so now this should technically destroy it. We're gonna hit compile and hit play again in our scene. And you notice the coins all disappear. But it's kind of lackluster, right? It just disappeared. So we want to now add a sound and an effect to it. All right, so let's do this. So before we destroy it, if I hold down Alt and click on that noodle, I can actually put the destroy node further away so we can deal with it later. Before we destroy it, let's be honest, we wanted to play a sound and we wanted to play an effect. So we'll just go over that kind of quickly. So we'll drag this node out and we'll say sound. And it comes up with a bunch of options: play 2D sound, play sound at location, or I think that's it. So, but we wanted to play the sound at the location, right? We don't want it to play at 0, 0. We wanted to play it where that coin is. So if the player's near it, we can actually hear it be picked up. So we're going to use play sound at location. And its location, we want to use the actor itself. But we don't just want to use the actor, and I'll tell you why. This is for the emitter. We're going to go through this kind of quickly. If we use the actor to play the effect and the sound, where's the effect? Where's the explosion going to happen? Actually, we'll just show it. We'll just show it. We'll show it instead of me just asking. So we're going to do two things. We're going to play the sound first at location, and we're going to type get actor location. Let's see if we can see it. Get actor location. So that's itself. We got its location. We need to pump that into those 0, 0 coordinates. Otherwise, it's going to play that sound at 0, 0, 0. And that could be so far away we can't even hear it. So we're going to take that return value, which is just a constant 3 vector. We're going to pump that in. So wherever we place that actor, we now have the coordinates in the real world. So we've gotten that actor location. Now when we play a sound, that's where we'll play. So let's just pick one of those explosion sounds that came default. So we click on the sound asset, and right there, explosive sound wave. We'll do that one. And just for the sake of continuity, we want that coin to still be destroyed. So we're creating a daisy chain. So first, player walks through the trigger, then it plays a sound, then it destroys itself. That's kind of the order we want it to happen in. I used to keep the destroy right there and daisy chain it off, and my engineers in my class would be like, no, it won't work. You can't destroy the actor and then play everything because the actor's no longer there. But Unreal Engine 4 would still work. They would, because a lot of times they put into the default that, hey, this thing won't destroy itself till it's gone through its full chain. But now it actually won't work in Unreal 5. So you have to put destroy on the end. So it goes through the chain and then destroys itself. So let's test it out. Assuming our sound works on our speakers up here. It doesn't, but it's playing on my laptop. Can you guys hear it? Let's fix this. Yeah, it's kind of a gunshot. There we go. Let's play it again. Perfect coin sound. So now we have a sound every time it picks it up and then it gets destroyed. Very cool, but we want a particle. We want to see something. It's that polish and bling, right? So to do that, we're going to hold down Alt, select that. We're going to move our destroy actor over a little bit. We want to do something else. We want to play an emitter. So it's actually spawn emitter at location is what we wanted to do. It spawns a particle effect at the location that we choose. And just for the sake of just to show you what happens, we're going to take that actor location, and that's where we're going to play it from. And then we're going to destroy the actor, hit compile, and let's play this. It's not even working. Let's try it again. Oh, you know what I didn't do? What didn't I do? You notice anything wrong with this? I didn't pick an effect, right? So a good explosion sound needs a good explosion effect. So we're going to go to this effect. We're going to go P explosion, compile. Let's try it now. So it's actually playing a little lower. We can't even really see it, right? So we have a problem. We want to see it. So let's try and fix that. So what we can do is we want to get the location of our collision volume. Actually, that would be something easy to grab it from. So right now we're using get actor location. We could go even more complicated and go into the add a number to that 3 vector, move it up a little bit. That sounds like a lot of work. So let's make sure I don't mess this up. But let's grab over here on our sphere. We can grab that and we'll type in location and see if it'll pop up. Get world location. So this should work. We're going to try this. This is get socket location. That might even work. But we want the world location of this actor, of this object. Okay, get world location. I accidentally clicked socket. So now it's getting the world location of that trigger volume, which has a center pivot on it. And that's perfect because that's where we want that to explode from. So we're going to tie that into our location of our sound and our explosion. Compile and save. And hope for the best. Here we go. Perfect, right? Looks like a coin. Looks awful. So here's what we're going to do. I think under files, I think I added that in here, I hope. I thought I added a coin sound. There it is. I downloaded a wave, any kind of wave file will work. So I downloaded a Super Mario World coin sound. And so we're gonna import that. So we're gonna go to content browser. And keep everything where it is. Import. There it is. SMW coin. Open. Okay, so we have a coin sound in there. Let's see if we can change. See if we can make it sound better, less jarring. So underneath the play sound at location, we're going to type in SMW. There it is, SMW coin 1, compile. And this means, this is just showing you how like easily you can just download any sound you want. Go to a free sound effects file or site, get yourself a waveform and pop it in there. So now if we hit play, you got a little coin sound. Doesn't match up right though, right? And maybe not the best one, but it's so much better. So let's fix really quick. This is something I usually don't go over in this class, but let's fix that. Let's fix that fire, that explosion, okay? We're gonna do it really easy. Type in explosion, there it is. You can see the P stands for particle. So it's a particle effect. Here's how we're gonna edit this. We're going to do this really easily. If we double click that, it opens up Niagara and you can see all the components that this is made of. If you watch this lesson, this tutorial, like if you just do this for this class, it's super easy. Just follow this and it's kind of a universal little pickup thing. But let me ask the class, what do we want to get rid of in this? The fire, right? So if I scroll up on this, you can see I've got a shockwave. I think we want to keep that. We've got a fireball. So we're going to just uncheck that. Actually, we're going to do this 2 ways. Actually, here's what we're going to do. I'm going to close this without changing it. Because I feel like I'm showing you a not proper way. I can actually just duplicate this. And we will call it P coin pick. We'll change it to fit our thing. Rename it. Change it from explosion to P_coin effect. Now we actually have something that's named properly. And now explosion, it disappears. So we'll type in coin again. There we go. So we're doing it right now. We've created a whole different file, so we're not destroying that starter content. So if we're working on a game with the team, and we just went ahead and changed something that someone else was using, it would fork it. So we're going to make a duplicate. It's now our own file. It's private to us, and now we can do whatever we want. So we're going to zoom up, and just like we said, we're going to turn off the fireball. Now there's no fireball. There's some sparks. We're going to turn off the smoke. And now it's got some shockwave, sparks, and a firelight. That's all we had to do to like really change that. Now that looks a little more close to what a coin pickup would look like. Maybe not exactly, but a heck of a lot better than an explosion. So we are just going to save this particle effect. We can close it now and open up our blueprint again. Right, and we will change this to from P explosion to P coin effect. Hit compile and play. We could adjust it, we could shrink it, but already a heck of a lot better, right? It's just something to show off whatever effect we want for our level. You can turn off the sparks. Like all we want is a little something something when you pick it up. But you can imagine this is now good enough to me that hey, we make that a key pickup or ammo or anything else. It's just showing us that we've picked it up, right? For a full game, what I would do a lot in video games too is I would recreate a rename, or a lot of times, like when I was working on in AAA, because we had effects and we had audio guys. For the sound effects guys, if I didn't have something close enough, and I usually didn't like to be close enough when I was working fast, I would make up a name and just type it in that slot that didn't exist. Or in the effects, I would make up an effects name that I wanted, put it in that slot that didn't exist, and then when the game gets played, it shoots off debug text that says error, no sound here, or error, no effects here, and those would come up as bugs for our bug testers, for people to actually fix. And so I would strategically add those bugs in there so that I knew that somebody would add sounds to my level and my game before it shipped, so that it was on task. And I found that that was an easier way than writing the whole list. And it worked well with them too, because when you get to the end of a project, if you don't have a bug written for it, they're like, I can't do anything if there's no bugs for it. It's like, all right, I'll make some bugs for it, right? So we would figure it out. All right. So it's 12:30 now. I'm going to go through the next section just super quickly, and not go through it as deeply as we normally would. I'm just going to show you really quickly now how to count these coins in your level. So we have it doing pretty much everything. The other thing we could do to this is when we talk about lights, if we go back to our viewport, I can actually create a light in here too. So we're going to add component light. I'm going to do a point light, which is a spotlight. Add it really quick in here. By default, it's really bright. It's about 5,000. I'm going to change the color of it to be more of a gold color. And we'll try lowering it to like 1,000. We'll see how it goes just for the sake of speed. And compile it. Now we actually have a light shining underneath our coin that's in our level. And so the cool part about this, if you have like a dark or a nighttime level, you can actually use these breadcrumbs as points of light to help lead the player. For example, the tower one, if you had a tower next to you with like some coins or some pickups that have lights on them, now you know to pick them up. And the nice thing is once you pick them up, those lights turn off. And so it indicates that you've been to that space already, right? So it works as a great indicator for that. As far as what we have now on our coins, now it's nice, kind of has a shadow underneath it too. But we can pick those up. The light turns off. We can put those down. So the next section we'll go over really quick is we now want to be able to count how many coins we picked up. So we're destroying this actor, so we can't keep a variable of data inside that coin because we're killing it every time. So we need to put it somewhere that will be persistent in the game. And usually a great place to do that for this lesson is just your player character. If your player character remains persistent even after you pick up those coins, right? So to do that, I need to create another blueprint set. So I'm going to show you where some other blueprints kind of hang out. And that is if I go into my content drawer, all of my content, we're now going to type in third, because that's our third person character. We're going to take that character blueprint. But you can see right here, it's under BP third person character. If we double click on this, it's the same kind of code we have for our actor, just a little bit more complex. So the way they've made the third person character in Unreal is they have the player controls in code, but they also have them in blueprints. And so here's the input mapping. If you want to reverse engineer, just check it out for your curiosity. This is all the controls for the player movement in the game. If you go down here, you can even see here's the jumping input. So when you press a button, it jumps. When you let go, it stops jumping, right? That's the code for that player. So in this location study, if I wanted to add this caveat that, hey, all of you, there's no jumping in your game, you could actually go through here, hold down Alt, and disconnect those, compile it, your player can no longer jump, right? Just Control Z those. But we keep it in there just in case you get stuck, right? But that's the kind of control you have. So over here, we want to create our own little set of logic that will play separate from that. So what we want is a begin overlap node, because we want to know when the player interacts with that coin. So we'll just start typing in begin actor overlap. But the thing is, we need to now know that he's interacting with the coin, and this isn't the coin logic anymore. So the way we do this is we actually cast it to another object in our scene, which is our coin. So we're going to click this event out, and we're going to say cast to object and cast a coin. And our BP coin object is in our library now as things you can cast to. So it makes it pretty easy. Since we've created that actor, we can cast to that actor. So we're going to look for that coin. We're going to cast to it. We're going to make sure the actor object, which is that coin, goes into that object so we know it's the right one. And now, just to make sure that works, let's print screen again. Or print string, sorry, not screen. Oh. And we're going to do hello again, just for the heck of it. We're going to compile this. And see now, every time that we walk into a coin, it should say hello. And it does, up there in the corner, right? So this is perfect. We're now speaking between the two blueprint classes. And it's okay if this is like, what the heck? Sometimes I look at it and I don't. It's like, it's code. It's the magic of computers. But watch the video again and just go through it. You can pause it to connect all this up. That's why I go like step by step on this. But essentially that creates that hello. But now we want to start counting numbers, right? So to do that, we have to create a variable. We have to create an envelope that will store that data of how many objects we've collected. So in this Blueprint class, we want to add a variable right here underneath on the component section. There's a variable section. We're going to click add, the plus button. We've added a new variable. We're going to call this points. Hit enter. And if you look at it, you notice it's a Boolean. We want to change that to an integer because we want it to count our numbers. So we're going to use this points to tell us what that is. So we want to get those numbers, and then we also want to add. So there are two versions of it. So if we drag this out, it'll give us either a get the points, so we can get the number that's inside that envelope, but also a set the points so that we can add to it every time we've picked up, right? So if we get the number right now, the default is set to 0. There are no points in there. Really, we call it coins instead of points, but whatever you want to call it. So we're going to grab it once more. We drag it out and set points. So I have to look at this a little bit. But every time we cast to the coin pickup, we want to set 1 point. Right? So this, and we're gonna save this thing right here for that print screen. We're gonna go over this quickly because we need to take a break. I'm sorry we've gone so long. Believe it or not, I had more. This is my problem. I do too much. So we're gonna set that every time we collect it. Every time we collect that coin, we want it to add 1 point to our envelope, right? So to do that, we're gonna take our points. And we're going to do, let's see if I can remember this. We're going to do add. Try this function add. There we go. It's math, guys. It's great. So every time we enter this, I want to add 1 point. And just follow along because I'm speeding through it. That says 10. We want 1. Okay. We want to add 1 point. And then after we've added 1 point to the variable, we want to tell the screen, instead of it saying hello, I want it to just count up. So from 1 to 2 to 3 to 4 for how many coins we have. So we're gonna, once it's done that, we're gonna send it over to there. And now to print the screen, the problem is this is an integer number, and we're just gonna try and pump it into that pink thing that doesn't work. And it automatically converts it for us, which is kind of the beautiful part. You can try to add a component that doesn't match up. A lot of times it'll figure it out and say, okay, we're going to convert an integer to a string for you so that we can print the number out of your variable. So pretty simple logic setup. What I like to do in class, and sometimes I use this as a reminder, is I will post some images of what this looks like too, so you can see what those nodes are, but then you can follow along in the video as well. Like, it's just practice and getting used to this, like, and then you start to realize what else you can do with it. But let's see if this works in the first place. We'll hit play. You see it typed 1 up there and 2, right? So it counted our coins, which is awesome. Now, no matter how many coins we put in there, it's going to count. Now, say, for example, we want to add 10 coins. I'm just going to go over this really quick before we take a break. We want to collect 10 coins and we want to count down now. And I won't go into the deeper logic. Maybe I'll add it as a separate tutorial. But say we want a win condition. So we want to make it some kind of a challenge. So we're going to count at 10. So what we can do is take this variable over here, that points variable, and we can change the default set value right here to 10. And hit compile. Now it's going to start at 10. But we don't want it to go 10, 11, 12, 13. We want it to go 10, 9, 8, 7, 6. So what number do we need to add to it? Get it to count down. -1, perfect, yes. Yeah, -1. Same thing as subtracting, right? Adding a negative to it. So let's try that. Well done. We only have 2 coins in our scene right now, though. But now it's 9 and 8, so it's going down. What we could do is now we could set up another string to print that says, congratulations, you won. And we could actually do a comparison to find out when that hits 0 and change that to a win condition, right? But we're not going to get, maybe we'll do that next week just to talk about, maybe for the side scroller, we could add something to that, but I'm trying to keep things like intro. Was that all new to all of you? Does that seem pretty, was it easy to understand? Did it make sense? Okay. So this is all recorded. So I'll either put it up wholesale without adding it or editing it, which I think will be fine. You'll just have to scrub through it. So I can get it up on Canvas more quickly. But it'll all be there. And luckily there were a couple students who were missing class today that had emailed me, so I wanted to make sure I recorded this today too. And so let's take, here, I'll just stop recording. Let's take